heard of Pert Network before?
No.
Pert Network developed in the year 1958 for the use and development of the U.S. Navy. Polaris submarine launched missile project. And it's a graphical sequencing and scheduling tool for large and complex and non-routine projects. So let's see how it works. Pert Network, these are the terminologies. We have an event, and this denotes a performance milestone. Okay, so an event is one of the milestones. An activity is a work or a job in the process. Time, you guys know what time? Time is estimated weighted times for completion of the activity. And it is 3 types. We have the optimistic, which is the most likely, and we also have the pessimistic, which is the least likely. And critical path is the most time consuming or the longest chain of required activities and events in a Pert network that must be completed on time, or else the entire project will be delayed. So did you guys get these terminology?
So this is optimistic.
Let's see. We will look at this example here. This is formula to calculate the estimated Pert time. Time, E estimated, equals the time optimistic plus 4 times medium or mean plus time pessimistic. So how many times do we have?
6.
6 times. You divide by 6. So here we will get the TE, time estimated average, TO optimistic, TM is the most likely, and TP is the pessimistic.
So what is the average? I mean, we need to differentiate between.
Yeah. Estimated is the average time. Let's say, for example, you'll make a pizza.
All right.
The optimistic time to make a pizza in 8 minutes. The pessimistic,
20.
it can take you 20 minutes. The most likely a pizza in 15 minutes. Okay? So if I want to get the average, I will take optimistic, let's say 8 or 9, plus 4 multiplied by the 15 minutes. So that's around 60. Plus the pessimistic, which is 20 minutes. You add them up, you divide by 6, you get the estimated average. Okay? Of course, this is like one formula.
Yeah, but when usually you use optimistic?
Yeah, well, we'll get you. Yeah, just hold on. The positive and negative aspects of the Pert. Pert is an excellent scheduling tool for anything that is large and something that is non-routine. So maybe it's not very great for the pizza. But maybe if we have, let's say, we want to order, let's say, 1,000 pizza tomorrow. Okay? And we want to make pizzas tomorrow. You have some pizzas frozen. We can use them. We got some pizzas that are, we want to start them from scratch. And we've got some pizzas that are already half made. And we want to put a plan for all of these to be done 1,000 tomorrow. So it becomes large and it becomes non-routine. It's not routine to make pizzas, some frozen, some unwell done, some from scratch. And it requires envisioning project in the entirety. You need to look at the project as a complete project. And it provides a tool for predicting resources needed and potential problem areas and the effective delays. So you can see if we delay in one component, how is that going to affect the whole process? And it is inappropriate, not appropriate for repetitive assembly line operations. So if we have an assembly line and we just make a pizza from scratch, all of them, then we don't need it. It is only as good as its underlying assumptions. Do you guys know what we mean by underlying assumptions? So we assume that this frozen pizza, it will only take this. And this pizza from scratch, we assume it will be, a normal, and it will take this normal average time. Assuming we have this normal ingredients, assuming we have, so there are some assumptions behind the plan for 1,000 pizzas tomorrow. So if we have good assumptions, good results. No good assumptions, no good results. And it can be too time consuming if you cannot computerize it. So there are some software more complicated that will do that. This is an example. And this is a simple Pert network. And we have a task. We want to build 3 dozen. You guys know what's 3 dozen? 3 multiplied by 12 equals 36 units of customized golf cart. You know what's a golf cart? Did you play golf? They're a small cart that you can drive. We want to make 36 of them. Okay? And we want to make them for physically challenged adults. Okay? So they need to have a special for the physically challenged adults. So we've got this Pert events. Number 1, receive the contract. Or A, receive the contract. So that's A. B, we want to begin the construction. That's B. C, receive parts. So here, we will receive parts.
What part?
Parts.
Equipment?
The parts, the components. So we will make the cart. We need the components. Maybe we need the wheels, and we need the body. Okay.
This is assembly cards.
Yeah, we want to assemble the cart.
Okay.
D, body ready for testing. So D here, we already have a body for testing.
Reactions.
E, we have frames ready for testing. So here is the event. We already have the frames ready for testing. D, we drive trains ready for testing. So that's F. Where is F? Here's F. We will drive the trains ready for testing. G, that is components ready for assembly. So G, it's ready for assembly. H, assembled. And then I, carts ready for shipping. I, ready for shipping. So what are the activities we need to do? Are these 1 to 10. 1, prepare final design. So that's 1. To prepare the final design, it will take us 4 1/4. That's the time estimated. Okay.
Yeah,
How do we calculate it? Based on the TO, optimistic, TM, most likely, TP, which is 6, time pessimistic. So you do the equation, you calculate it, you get 4
And the
1/4.
last one is the average, yeah?
It's the based on the equation we just looked at. It's based on this equation. Okay.
Yeah.
So you take the TO optimistic plus 4 times TM plus TP divided by 6. If you use this equation,
Divide by 6. Divide by 6.
yeah, to get the average. To get the average.
Usually the average, the total.
6 times.
Now that's number 1. We prepare. Now number 2, we want to purchase the parts. So if you look at purchasing the parts, it will be activity number 2 here. Here we need to purchase the parts. 3, we want to fabricate the body. So that's here when we fabricate the body. Number 4 is the fabricate the frames. So that's what you do here. You get the frames. So probably here there are 3 routes to get to G. Of course, G is you get it ready for assembly, right? So in order to get this, there are 3 routes. These you need to purchase. Here you already have the body, you just need to fabricate it. And here you need to get the frames. Now number 5, which is building the drivetrain, which is right here. Number 6, you test the bodies. That's here. Okay, and then you have the time. And then 7, you get testing the frames. And that's number 7 here. And then we've got number 8, testing drivetrains. That's right here. So you can see here, if you do this route, you need 6 plus 2 plus 2. That's around 10. This route, it will be 7 1/4 plus 1, so that's 8. So this will be faster. If you take this route, it will be 3 plus 1, only 4. So this is even shortest, because this route here, it's already, almost more than half ready. Here, it's, you know, maybe half. Here, there's nothing, you need to prepare it from scratch. Just like similar to the pizza example, where you have some pizzas from scratch, some pizzas half, some pizzas already ready, you just need to heat them. And then once you get to point G, that's when the component's ready for assembly. And then you do 9. 9 is you assemble the cards. And then 10, that's when you test the cards. And then the testing will take you around, you know, 2.25 time. So with this Pert network, it show you the events, it show you the activities, it show you the time that it will take for each of the activities. And based on this, you can get a very good picture into how things will be ready. So if you want to make 1,000, we know how many we have here, how many we have here, how many we have through here, how much time will be needed here, how much time is needed on these steps. This way we can make better judgment. So if we're going to make pizzas, we know that, you know, each pizza will take around maybe 4 hours. Then maybe we need to, you know, or maybe 4 minutes, you know, depending on what time unit. So how much you need to get through B to G, how many we can get B to G from this route and B to G from this route in order to achieve our goal. So the idea with this whole thing is give you an idea of how planning with time can be used using graphical interfaces for you to understand that, you know, when we make a project, we need to watch out how the different components can lead to what results. Now I'll take your question.